Okay, so I am going to do a video today on records because it's been requested, but also because it's highly important. So in this video, I will cover the basics of records and instances. Alright, so what is a record? Well, a record, simply put, is a way to it's the same as a struct in C++. So I'll just write this in. A record is a way to collect multiple pieces of data together, often of different types. It is similar to the struct in C++. And that's basically what a record is. So why would we want a record? Well, let's say we want to express a point on a graph. Okay, so we can say that a point on a graph we can say it's like an int. Okay, so let's say we have 2 points. I want to do a distance function. Okay, so we'll take 2 points, int, and we'll give back a real. So, well, if let's say for here, we'll give in a point with a and b. Let's do x1, y1, and another point x2, y2, like this. And what we're going to do, we're going to do something like square root of something. So we have to do x1 minus x2 square this, and then this pluses y1 minus y2, and we square this. Cool. And then all of this needs to be turned into a real first before we can use it with square root. Okay, so like for example, this is a simple function, so we could say start equals distance between, I don't know, what's a good function? Let's say 3, 4, and 0, 0. So this is a triangle. This is a perfect right triangle like this. Okay, so yeah, this will give us 5. So this will generate 5. It's saying that the distance between these 2 points is that. But the problem about this is that we have very little control over these elements in here, and they're restricted to just integers. So this is possible, yes, but it's not ideal. So a better way to express points than using tuples is to use a record. So we can make a point record. So we'll call point. Okay. So what is point? Point is going to be, we'll say that point has an x. We can say point has an x like that, and it's an integer, and we have a y, which is an integer. Okay. So now we define that there's this record called point that has int and int. It contains 2 points. So how would we make a point? So we can make a point by saying, well, let's say we want to make the 3, 4 points. So we can say start is equal to create a point, I say x equals 3, y equals 4. I don't have to write point in here. I just need to say that in this, the fields x is equal to 3, y is equal to 4. Okay, and if I compile this, you see it automatically detects that it's a point record. Why? Because we've defined that any record type that has an x and a y like this is a point, and so any record type that has an x and y that takes in that is a point. So it matches. It says okay, that's a point. So well, I'm not going to put it here. So I'm going to say that, well, let's say this is P1. Okay, so I'm going to say P1. So P1 is a point. This type signature here is actually kind of important. But for now, I'm going to write it like this. Why? So that it's convenient and I don't have to keep running it. So here I can define, and just for the sake of it, I'm going to define another point. I'm going to define origin. So I'm going to find the point of the origin point, and origin is going to be equal to x equals 0, y, blah, blah, y equals 0. Okay, so we have a point and origin. So let's define a distance function. So we're going to redefine a distance function, except this time it's going to take a point and a point. Okay, so we're going to take a point, 2 points, and what should we give? Well, we can give the same real. Okay, so how is this going to work? Well, it's going to work about the same. So I'm just going to copy this code here. So we're going to do this, except now this isn't x1, y1, and we can't access it like that. Okay, that's fine. Well, let's call these points what? Let's call them A and B, okay? So how do we access something within a point? Well, so A is now referring to the entire point, okay? So if we pass something into a function, a point in a function, the entire point, this here, this 0.34 is now A, and the entire point whatever else, so let's say we pass origin here, will be stored as B. So if we need to work with it, we can do something like this, where, well, we know x1 was originally the first x of A, of what's now A. So we can say x1 equals A dot x. So we're this dot, this is an operator. It was saying is that we extract from the record A the x field. So it's going to give us exactly this x. So x1, the type of x1 is now integer, because we know that this is of type integer. Okay, so we can do the same. So we can say y1 equals a dot y. Oops. X2 equals b dot x, and y2 equals b dot y. So if we do this, what we're doing is we're extracting each of these points here, like that. Okay, so we extract them and then we pass them in here. Okay, so let me see. So well, from here we're gonna say that we extracted those. Okay, cool. And then let's say start equals distance between, let's say, origin and P1. So if we do this, this should give us the exact same, oops, this expected instead of this, 1817. Oh. So yeah, this gives us a 5. So what we did was took a problem that we previously would have defined it using int and int like this, and we changed it into something that's more concrete. So we're saying that point.x, point.y, something that has an x and y in it. And the code really hasn't changed much at all. In fact, I could have put a.x, a.y in here, but I want to show you guys that if you had code that works for it otherwise, you can use the exact same code and just do this. So that works just fine. Okay, so it is possible to do that. Now it is also possible to write it in with a pattern match here, where you do x equals x1, y equals y1, like that. You can pattern match it like that. The only problem about that is that it's great, it's a little messy, but it works as well. So you can use pattern matching. You can do a lot of things like that. Now when you have a point like this, let's say we have point like this, and this is the sign. Now let's say we want to define whether or not a point is whether or not we want to do some things like sort a point or whatever, or add or subtract a point. So if we were to do start equals P1 plus origin, like this right now, we would get a problem because it says plus no instance available of type point. What this is saying is that the compiler, it knows what addition does for every other type, but it doesn't know how to add two of these guys. So we have to tell it how to do that. So As of right now, it does not know how to, but we can do that. So how do we do this? This is with the use of instances. Okay, so what we're going to say, we're going to make an instance of addition for the point type. So this is the first part of our definition, okay? So we're saying that we're doing that. Now we're going to say where. Where what? Well, where, if we do addition on, well, let's use A and B, okay? So where addition on A and B, well, how are we going to add them? Equals, I don't know. Well, we're going to do A dot, we should build a new record. So we're going to give a new record out. Why are we giving a new record out? Because addition always takes one type and another of the same type to give a third of that same type back out. So it's expecting a record back out. So we're going to say the new x is going to be a.x plus b.x. And the new y is going to be a.y plus b.y. So you can do this. Now, some of you, if you attended class, you might have seen this written out like this in one line. It doesn't matter. It's actually completely the same code. So I can write a one-line instance, or if I'm to do it in more than one line, you just have to make sure you indent it properly. It's perfectly legal. For now, I'm going to keep it one line just to make our code clean. Okay, so now I've defined the instance. So I've said that in the case of addition for a record, we need to do this. So let's see what happens. Oh, it knows exactly what to do. We can say P1 adds origin. Well, let's try something that will actually show some results. So P1 plus P1. So we're doubling it. Oh, there we go. 6 and 8. So we took that record and added it to itself. And that's cool. So now we can add records. In fact, maybe we might want to also subtract records. So we can also start doing that. So we do point where minus AB equals, well, in that case, I'm just going to copy this and I'm just going to do minus, for example. So we can check that. We can check, well, what happens when we subtract it. And yeah, 3, 4 minus 3, 4 should give us that. Yeah, cool. So as you can see, we can use instances to do a lot of cool things. So equals P1 minus P1. So there's a lot of things you can do. Now, why would we want an instance? So you can write a separate function. So let's say we want to add 2 points. We can do like add points. It takes 2 point, and gives us another point back out. We can do this. We can do add points, and we can say add point A and B is equal to x equals A dot B, A dot X plus, I'm lazy, just gonna copy this. So it's perfectly valid to create a separate function like this. My bad. So this is a separate function that adds 2 points and returns a third point out. So it does identically what this does. And if we want to make it infix, we can even add an infix. We can even infix it like this. So we can even do something like start equals add points. We can do something like P1 add points P1. So we're adding 2 points. It'll do the exact same thing. So why do we want to, what's the advantage of using addition? Well, one of the advantages of using addition is that it allows us to use pre-built functions. So let's go to Klugo and look up what these pre-built functions are. So if, let's say sum, okay, sum on a list. Okay, so if we sum on a list, what do we need? So I'm gonna copy this here, this definition. So the pre-built function definition of sum is this. So it says that given a list of, and I'll just remove these, given a list of some type A and to give another type, we need to have addition and 0 defined for that A. So what if you want to add an entire list of points? Well, let me create another point to play with. So we'll say P2 is a point where P2 is equal to x equals 1, y equals 1. Okay. So why do we want instances? Well, let's say we want to add an entire list. So let's say I have a list of points, sum start equals, and let's have a list where there's P1, P2, and the origin. And I want to sum them up. So I want to sum them up. Well, I can either write my own function that does that, but what I could do is I could just use instances. Now, as you can see, sum requires a 0. So we'll just have to define that. So in order for sum to work, we need a 0. So for sum to work, we need a 0. So we'll define that as 0 instance. So we'll say instance of 0 on point, okay, where 0. So 0 doesn't need any arguments. We just need the 0. So what's a 0? What's a 0 point? Well, we could say it's x equals 0, y equals 0. So we're defining the 0 point as the origin, which is great because we actually need a 0. We need a 0 point. So that's the origin. So now let's try summing them up. Oh, hey, look, it added them all up. So we did 3, 4, and we added to 1, 1, and it worked. That's pretty cool. So it added up all of these points. We can do a lot of other things. So for example, let's say we want to check isMember. So I'm going to do isMember. Okay, so for example, we know that isMember, ignoring all these extra things, isMember requires, let's knock out some of this so it's easier to read. So what's isMember? isMember requires, isMember will check if something is a part of a list of that thing, and it will give us a true, but it requires equals. Okay, so we can say that if that we have start equals, like, let's say isMember, we can say is P1 part of this list, P1, P2, and origin. So we need to check, well, is P1 inside this list? As it is right now, we can't say that because it will say, well, we don't know what equality is. Okay, so we'll say isMember requires equality. Okay, so we'll establish an instance. We'll say instance of equality on point where EQ of A and B. Well, how do we say that they're equal? Well, we could say if their x's and y's are equal. So A dot x equals y dot B dot x, and A dot y is equal to B dot y. Like that. So why can we do this? Well, we know that x and y are integers, and we know that we have equality defined on them. So we can say, we can compare them, and we can also now add, we can compare them, and then we can put the results together. So now we can check if it's equal. Whoops, different number of members specified. isMember, my bad, A 50 equals point where equality on A, B, A, oh, my bad, equals, not equal, there we go, my bad, there we go. So we have to define the equal operator. And isMember P1, is it P1 inside there? Yes, it is. We can even check. So in this case, yes, P1 is inside of this list. We can also say start is equal isMember, and let's make an entirely new record. So x equals 100 and y equals 100. So some random point. Is this point among these points? Well, no, it's not. But we can check that. False. So this is kind of the cool thing, is we use these instances to define operations and stuff on our custom types. So our records we can now use all of the built-in functions. And this is actually great because we don't want to write an isMember specifically for point. And there's also another reason why we do this. So what's a thing about, let's say our point here, we don't want to just use integer points. Okay, so we don't want to just use integer points. We want to tell that point Well, let's say point it can take real numbers also as well. Well, then let's give it that capability. So if we want to make it so that point can take a real, but it can also take an integer, let's give it the flexibility. So we'll provide an argument a, like this. Actually, I'm not even gonna call it a. I'm gonna call it new type. Just to emphasize the fact that you can call it anything. So when we create a point, we have to tell it, we have to give it a type, and then we'll just say x and y will be exactly that type. So what changes here? So now whenever we declare a point, we have to tell it what the type of that point is. So here, because it's a point of integer type, we have to declare that. But now we can also declare points of other types. So we can declare a point of real type. So we could say P3 is equal to x equals 1.23 and y equals 4.56, something like this. Cool. But then now every point here we go, okay. So now we define that we can have points of variable types. It can be a dynamic type. It can take in a type and do stuff. But now we have to change everything. So one thing to keep in mind is that when you define a custom type point, put parentheses around it when you write this, because then it treats it as one argument and not two. Now another thing here is like this distance. Now let's change it to work for this new point of any type. Okay? Now we're going to just say a here because it's just for convenience. But what I'm going to say is that, or actually I'm going to call this new type. Let's call it new type. I'm going to call it new type because I want to express it. So distance between a point of some type and another of the exact same type should give us a real. Okay. Now here's the thing. How is this going to work? Well, we have to do the same thing. So this code doesn't change. Whatever that point is, we have to set it to there. We have to still do all of this operation, and we still have to do to real. That's cool. Now we do have to change the code a little bit just because we have to make sure that this squared will work. So I'm just going to move this to real now inside here, and then raise it to 2.0, and then to real here, and then 2.0. Or actually, I'm not even going to do it that way. I am just going to stick it outside here. So to real, to real, to real, to real. So I'm going to real everything. So now we know all of our operations are real. And now we don't need this extra outside. So because everything is already real. So now whatever the type is, it will be converted to real. That's cool. And this should work too. Cool. Now let's try that here. So we'll go, let me check if my start's gone. Okay, cool. So now we can try this new start, and we'll go, well. Yeah, lots of new errors because now that I'm changing my record type, auto instances don't work. So for now, I'm just going to comment them out, and I'll show you guys how to fix it in just one moment. So this new distance, let's try it. Overload to real cannot be solved. Distance. So why can't it be solved? Well, we have to tell it that to real is defined for our new type. So this is where this should work. There we go. So why was it given a step? So it's saying that internal overloading of to real could not be solved. This happens when the compiler doesn't know what it needs to do with something. So now here, that's why this is required. So I'm saying this distance, we're now going to put a requirement on. We're saying that whatever this type is, it has to be, we have to be able to change it to real. And that's important. So we're saying that in order for this to even work, it has to be able to be converted to real. And then after that, it works, everything else works out. So all of this will work given that this type has to real defined for it, which if we check integer, integer has an instance for to real, and so does real. So this will work. That's cool. That's cool. Now let's try something else. So let's do this. So distance origin b. So now let's try fixing these instances. So how do we fix an instance for a record like of this type where it has random type? Okay, cool. So what we're going to do here is we're gonna put it here, and we're gonna say, nope, not that. We're gonna say new type here. Okay. Now, so what we're saying is the point of some type here, a new type. But now let's just add some conditions here. So we have to condition it because we have to say that this plus thing here. So let's say we run this as if right now. So we can comment out the rest for now, and let's us move this here just to show what happens. So here it's gonna say like this again: internal overlaying plus can't be solved because this is a flexible type. So if we stick in a boolean or a string, it won't know how to add it, and so it doesn't. So we have to let it know. You have to tell the compiler to restrict this addition instance to points of types where that type can be added. So that's why we have discard here. So we're saying, and this is why I'm going to break this off so it's more readable. So we're going to say instance of addition on point of new type where addition is defined for the new type. So if addition is defined for a new type, now we can do it. Okay. Now you can see it adds it. So that's why we have this conditional thing. And this is the exact same thing as what we have here, where we're adding certain conditions. So as you can sort of guess where we're going with this, we have to do that same thing here. So now I'm going to break into a multi-line just so it's a little more readable. So again here, point, we're going to have to stick inside parentheses so that now point new type is there. And now we also have to define that my subtraction is defined for a new type. So given that subtraction is defined for a new type, we have that. And we can check it. So will it subtract these two values? Yes, it will. That's great. Okay, so let's try the rest. Okay, so add points was just to show you guys that, which actually now is completely null and void. So I'm actually going to comment this out so it won't fuck up the rest of our code. But now we need to fix some things. For example, for sum to work, we need a 0. But the problem is that if we put a 0 here, so if we try this again, it will say conflicting kinds, ... So yeah, here it will be like, well, point doesn't exist. So we can put point here, new type again. But if we do that, we see that there's problems again. So we need to say that, okay, we need to again define this condition thing. So we're gonna say that 0 is defined for new type. Okay. Now the problem here is that 0 is a specific type. It's integer, but we have to return a point of that new type. So instead of writing 0 and 0 here, we're going to just tell it to set x to the 0 and y to 0. So what does it say? We're setting x to the 0 of the new type and y to the 0 of the new type. Okay? So if we check that, now it works. So x, instead of writing 0, we can't write 0 because it can be a real, then we need 0.0. And if it's int, it needs to be 0. So we just write 0, so it takes the 0 of whatever this type is. So if it's integer, it'll put a 0 here. If it's real, it'll put a 0.0 here. So that's how you start fixing these. Okay. So now let's see what else we can do. For example, it's member. Well, we know we need equality, so now let's fix this. What happens? Point on a new type. Okay, cool. And I'm just going to do a multi-line just so it's readable. Okay, cool. But now we have to restrict this. So we have to say that given that equality is not defined on new type, So if we have equals defined for the new type, now we can do this. And now we can check this. So there we go. So what happened now? We now have the ability to create points that aren't just integers. We can create points that are of real numbers. We can technically create points of booleans, but it won't be very useful because none of the instances would work for a point of type boolean. But we can at least make points of type integer and so on and so forth. Okay. Now the good thing about records is you can also nest records. So what do I mean by we can nest a record? Well, let's say I want to make a new record type. So I want to make a circle. Okay. So what's a circle? Well, the circle will say that it has, well, it should have a center. So a center point. Well, what's a center? Well, the center will have to be a point type. Point, I don't know. We can say point, what type do we want? Doesn't matter actually. We can say we can say it's a point of point A or something like that. Now the problem is we don't know what type point A is, so we're gonna have to say circle of something. Okay. So in case we want our circle to be in integers, we have to take that in. Now we could do a radius. Now let's say we want to have a radius. Well, our radius, we can make it a completely different type. So let's say we want to make this type separate from this type. We can add another type B or something, but we'll keep it the same. So what do we have now? Now we have a record that has a record inside of it. Okay, so this sounds confusing at all, but let's see what happens. Start is equal to, well, we need to make a circle. So we're going to say center is equal to, well, what kind of center? We can do x equals 3, x equals 0, y equals 0. And we can say that the radius is equal to 5, like this. So we're making a circle, and yeah, it's at 0.00 with 5. Now why this is confusing for some people is, well, where did we declare A in here? In here, did we declare A? No, we didn't. So how does it know what A is? Well, it doesn't actually. It doesn't know what A is. So it's going to say, well, what circle is of type A? What is A? We didn't give it, so we have to figure out. Well, we know center is of point A, and what is the type of this? Integer. So now it knows that A is an integer. So now radius we know has to be an integer, and circle has to be of type integer. So for example, if we do 5.0 here, this will give us a problem because that's not the right type. They don't match. So that's how you make a circle. So we could say, this is a circle. So we could say C1. So circle 1. C1 is of circle int. And in fact, I could do one better, and I could just throw origin here, because I already defined origin. See? So now we have a circle. So what's the circle? The circle has a center and stuff like that. Okay, so let's make more circles. So I could say circle, let's say real. Okay, C2 is equal to center equals, let's grab what's our real point here, P3. Okay, so P3 and radius is equal to 10.0, something like that. Actually, 1.23. Let's just say something like that. Okay, so now we have two circles. Okay, so what's something that we could do? Well, when you're inside of circle, let's say the origin circle here. Well, what if I want, so inside C1, what if I want the x coordinate of the center? In that case, we can do multiple extractions of field extractions. So from C1, we can extract the center. Now that we extract the center, we can then extract from the center, because the center we know is a point type, meaning that we can extract from that instead also. So we can say start equals C1.center.x 0. So the x coordinate from C1 is now 0. That's cool. That's cool. So what are some cool things we can do with it? Well, I don't know. Here we can say, well, how can we say? Let's say overlap. So let's write a function that checks if two circles overlap. Okay, so we can say circle A and circle A. So two circles are the same type. Okay. Now what will we do with this? Well, let's say we have circle A and circle B. Okay. What do we want to do? Well, we want to check, in this case, if the distance between the two, if the distance between the two circles is it greater than the bigger of the two radiuses. So this is sort of a problem that requires a bit more thing to handle. So okay, that's cool. That's cool. So we're going to say that let's actually do something extra fun. We're going to say that these two circles can be of two different types. So circle A can be of type A and circle B can be of type B. Cool. So how are we going to do this? Well, I'm going to do a where statement. Why? Because there's going to be a lot of calculations and I'm just going to make it easy. So I'm going to see center A is equal to A dot center. So we grab the center from the first circle, and we can say center B equals B dot center. Okay, cool. Cool. Now let's extract those specific parts out of those. So I'm going to say A, so I'm going to say, so let's see, how do I run this? So what I'm going to say is that center, well, we're gonna say that because we have a distance function, but our distance function is not made for two types. So you know what? Let's go back and fix our distance function to work for two types. So we'll make the distance function work for two types so that we can make it work here. So how will we do that? Well, we'll do other type here, and we'll say that toReal has to be defined for new type and has to be defined for other type, like that. So we can actually check this. So how do we check this? We can say start is equal to distance between, let's say, P1 and P3. Those are two different types. Okay, so let's check that. Instead of toReal, what did I do here? Uh-oh. Oh, 26, my bad. 26 is given that it's equal to toReal new type and toReal on the other type. Whoops. That's expected. Let me try without the comma here. Sorry guys, I forgot how to do this properly. Class is expected. Oops. Okay, so we can't make distance work for two types yet. Well, I'm going to have to show you guys that some other time then, because, and I apologize for this, because right now my brain is doing stupid and I can't get that to work. Alright, so let's make this, let's keep our live symbol and keep them the same type. So assuming they're the same type, we just need to get their distance. So we're going to say distance equals, so we're going to say dist is equal to, well, let's get the distance between center A and center B, like this, okay? And then let's do max rad equals, so we need to get the bigger radius out between the two of them. So how I'm going to do that? Well, I'm just going to extract the radius, and I'm just going to do, okay, I'm going to do max, I'm going to utilize lists fun stuff. So I'm going to say a dot radius, b dot radius, like this. So given the center of A and the center of B, we're gonna get the distance. Actually, we don't need this separately. We can just stick to here because it didn't save too much. So we'll just do it like this. So distance between the two circles will be A distance between A center and B center, and the max radius will be whichever one is bigger. Okay. So then we'll say if dist is, well, they have to be farther apart than their max rad, so greater than max rad, like that. So this will check if two circles overlap. So we can check that. We could say, let's make another circle. So C3 equals, C3 is a circle of integer also, and C3 is equal to center. Let's not do at the origin, let's do it at equals x equals 3, y equals 3, and radius of 2, something like that. Now we can now check if they overlap. So we're going to say C1, C3. Now I know this is going to make an error because I didn't do one part, which is not what I expected, but here. So this expected inside of an outside token, and then if I, okay, so we didn't say what it will do. So this will be a Boolean. Cool. Now if I do this, now it says cannot offer demand type referred type near distance, a dot center, b dot center. So here it's good, it's asking a lot of problems. So most of this is probably because we did not define that type A has to be of type where it can, no, actually should not. So here distance cannot identify function a dot center, right. Is it distance new center so I messed something up here and I apologize. Maybe I'll cut this part out of the video, but center A is equal to A dot center, center B equals B dot center. Nope, I didn't do anything. Where I messed up, I actually honestly have no clue now. Because we're offering a list to a list. C1 is type origin. I actually have no idea what happened here. Something messed up here, where this distance cannot unify the demand type, and I am not actually sure. And I apologized for this, guys, because this worked before, but it's been a little bit. Okay, well, we can skip this part because I was not able to make it work. But the idea that I want to convey, more importantly than trying to solve a problem that I made up on the spot, was that you can grab you extract an element and then extract elements from there. So you can repeatedly extract elements. Okay, so from here you can repeatedly extract elements from each other, and based on that you can also you can also do some pretty interesting things. So what are other interesting things you can do with that? So since this hasn't worked, I'll delete it. So let's say we have some other record. So let's say we have a person record, which is easier to handle usually for me. So string, name and string, it will have their age is an integer, and we'll say that the birthday is, well, let's call this, let's say birthday is of type date. So we'll define a record type specifically of date, like this. So date, we can say has a month of type, let's say it's a type month, and we can say that, well, let's not do ATTs in here. So we'll say it's a type integer, and we'll say it has a day of type integer too. So we'll save ATTs for a different stream, but for now we'll just cover date. So let's say we have a person. Yes, that. So I'm going to say Evan is a person record where equals name equals Evan, age equals 1, and birthday equals month equals 12, day equals 9, something like that. So now I've created a person record, and there's a record inside of a record. Now let's say I want to sort it, let's say make another one. So I'm going to make another random record. Let's do something like that. Okay, so how are we going? What can we do with this? Well, we can start doing some fun things, like we can say with person we can define an instance where an instance on person. Well, when are they equal? Well, we can say they are equal where equals on person A and person B is the same as A.name is equal to B.name. So if they have the same name, we'll say that they're the same person. We can also add more guys. So we can say if age dot, let's say they have the same age. So A.age is the same as B.age. And let's also do another one. Let's say A.birthday is the same as B.birthday. Now this will fail because we haven't actually defined an equality on date. So in order for this to work, we also need to make an instance on date. So we can do it this way. So we can do equals where given two dates, when are they equal? Well, we can say that they're equal when the month and the day are the same. So we can say A.month is the same as B.month, and when A.day is the same as B.day, like this. So we're defining equality on dates so that we could define equality on birthdays here. And then from there we can do other stuff. So what other things can we do? We can define an instance of well, it wouldn't make sense to do an addition instance on people. It would not make sense to do a subtraction, 0 or 1, but we can't divide people, but we can sort people. We can say, when is one person bigger than the other one? Well, we can say that a person is bigger, that one person is greater than another person. I'm all for people equality, but just for sake for exercise, we'll say when one person is older than the other one. So we could do something like a.age is less than b.age. So something like this. And then, so from here, you can do a lot of interesting things with people if you can have something like this. And from here, we can like even sort. So if we have a list of people, we can now sort them. And if we default the sorting by age, we don't have to make our own sorting function. So I can make a new thing like here, string goes. So I've defined 3 people here. So now that I have all these instances, what can I do? I can do start equals sort. So if I have a list of people, like this, I can tell it to sort it, and it will sort them out. Whoops. 90 instance where equals is a end of group of layout inspected instance equals person where equals that end of. What did I type? I typed something wrong. So here, this shouldn't be the issue, but let me check. End of group with layout expected instead. Oh, that's right. Equals. That was the dumb part. Okay. So, oh no. Oh yeah. Equals. All right. So there we go. So now we sorted this. So we sorted our list of people based on their age. So I got sorted in first, Tringa next, Hassan. So you can sort a bunch of records like that. So you're able to actually, do that. Another thing we can do is, for example, if let's say one cool thing we can do here is we can do, let's say you have a prompt that says find out people who are younger than a certain age. I can actually do something like this, where given this list of, so let's use this list here, like this. If I want to sort it for people who are younger than a certain age, so I can take out each X, pass it back there, but I can filter it. And how am I going to filter it? Well, I could say, given that X is less than, because now it's age based, so we can create a temporary person record here to sort people. So I can create a person where name equals we don't care, age equals, well, what's our target age? We could say we want people younger than 50, and then everything else can be whatever. So we can say birthday equals month equals 0, day equals 0. So basically we don't care about any other thing, we just care about this age part. So here now we can sort for just the people who are younger. We can just filter out only the people who are younger than a certain age by using the instance that we've defined and creating it like that. And in this case, we can actually make a function. So let's say I want to do younger than. Okay, so it takes an int and a list of people. So we can say list of person, and it gives us a list of person back. So it filters it out. So what we can say is that younger than an X in a list. Okay, so given a list of people, Well, what we're going to do, actually, let's call this n so that we don't have conflicting variable names. Well, age is now n, and now we can filter out people based on a specific number. So I can actually do start equals younger than 50 on this list here. And now we have a sort of customized thing to sort people. And did I need to make a specific function? No, I just made a instance and then exploited the instance to sort people, to filter out people. So there are many ways you can do this. Let's see, what else do I need to cover? So this is records in a nutshell. I'll cover one more topic about records. So let's say you want to update a record, but without you want to update just one field in the record. So let's say here, Evan equals like this. Let's say I want to do something like a function called new birthday. So new birthday would take a person and give a person back. And all this function should do is it should basically make them 1 year older. Well, what I can do is instead of it is possible, so I can say that, okay, if that we should do name is equal to a.name because we're copying it, and then age equals a.age plus 1, and then we say birthday equals a.birthday. So nothing changes except the age here. Now, as you can see, this starts getting a little strenuous to type just because we have to type so much. So one thing with records is that you don't need to do this. You really don't. All you need to do is do this. So since you're just everything else is staying the same, all we need to do is we can just remove everything that stays the same, like this, and we're just going to say and a and age equals that. So what it's saying is that it's going to copy a, but just we're going to update specifically that. Like that. So we can say start equals new birthday on Evan. So like this. So if we look at this, multiply define. Yes. Whoops, my bad. So what we're saying is that it just took my record and it copied everything, but it just updated just the age by adding 1 to it. Like that. Okay. So that way you don't have to type all of this, you can just type that. And it makes your code much nicer and easier to read. Alrighty, I think for the large part that's pretty much everything about instances specifically. I will do a separate video later on ADTs and trees and all that other fun stuff. What I would suggest is definitely practice instances and records, because records are a better way of storing information than using tuples for efficiency reasons, for organization reasons, and instances will make your life beautiful. For instances here, you just, do that. It makes your life easier. Oh, I should cover one more instance here, just because some people don't realize this. So let's say you want to use a toString. So you want to toString, like in C++ and Java, you want to print something out, you would need to use a toString. You can instantiate certain things like that. So if you want to instantiate toReal, toString, toInt, you can instantiate those two. So let's say if I want to instantiate toString on a person, well, what would that be? So toString of a is equal to a.name. So basically, if I want to toString a person, I could say I just want to print their name then. So toString Evan. This should just print my name out. So you can instantiate not just basic operators, but also things. So I can instance, let's say I want to instantiate toReal. Let's say to int. So let's say for some reason I want to instantiate a person to an integer for some reason. So in that case, I can do where toInt of a is equal to a dot, let's say we just grab their age. So in this case, I can do start equals toInt like that. Yeah, we grab just his age. So it's also possible to on records, and this isn't just records, this applies to ADTs and everything. You can instantiate not just basic operators like equality, greater than, addition, subtraction, but you can also instantiate things like toString and toInt so that you can do even crazier things. And toString, toInt are some of the more common ones. I'm trying to think what else there are, but those are the ones that come off the top of my head. Alright, I hope this helps everyone. As usual, this file will be uploaded on my repo, and this video will be on YouTube in just a moment. So, ta-da! Have a good day.